Hi everyone, in this video we're going to go through the revision sheet. I don't have much time, so hopefully it'll be a short video. I apologize if I do rush, but I've got about 30 minutes, so I'll try to fit it into 30 minutes. Okay, so with question 1, we've got state the transformations of each of the following quadratics. Now what it should actually have added in that we're going from the basic quadratic, which is y equals x squared, to the quadratic in turning point form. All right, so that's what's going to tell us the transformation. So A is your dilation, H is your horizontal translation, so translation, left or right, and K is also translation, but it goes up or down. Whoops, can't spell down. Now, when you do go into VCE methods, we tend to move away from left, right, up, down, and we say you're going along the positive or negative direction of x-axis or y-axis. But for now, you can just use left, right, up, down. And also, if you've got a negative A, it's a reflection. So I'm just going to squeeze that in. Now, these notes should be in your bound book. Okay, let's push on. Whoops. I want to do a different color just to differentiate from those notes. So we do have a value of H, which is 2, and a value of K is 5. Now in this case, A is just 1. Now when A is 1, you're not being dilated. So if you multiply something by 1, it stays the same. There's no dilation factor here. So the 2 means we've shifted to the right 2 units, and we've gone up 5 units. All right, let's move on to the next one. So again, identifying A, H, and K. Now this one, we do have a value of A that is not 1. In this case, it's 2. A value of H is -3 and K is 1. Now, if it helps, when you see the plus sign, you can write 2 negatives because our general form of our turning point form has the x minus. So if you feel like you're going to get mixed up, make sure you've got that in your notes or have an example just so you can refer back to. All right, so the 2 means we've been dilated by a factor of 2. So of 2 units from the x-axis. Now you can have dilations from the y-axis, and that's something you'll learn in year 11. Okay, but for now we're just doing a dilation from the x-axis. We've gone to the left 3 units. Whoops, forgot the word 3 or the number 3. Left 3 units, and we've gone up 1 unit. All right, so for the next one, we've got quite a few here. A value of A is -1, so that's mean it's been reflected. And when we talk about reflection, you can have a reflection in the x-axis and the y-axis, but for now we're just doing a reflection in the x-axis. We're not going to complicate things just because you're starting to learn about parabolas. H is equal to 4 and K is equal to 7. So I'll just write the first one here. Reflected along the x-axis, or in the x-axis, along the x-axis. All right, so just kind of picture me doing my parabola and then I'm bending over. All right, that's what it means. It's been reflected. We've gone to the right 4 units. And we've gone up 7 units. All right, one more. A is equal to -0.5. H is equal to -5 and K is equal to -2. So the A being both a negative and a number other than 1 means it's been dilated and reflected. So reflected along the x-axis, dilated by a factor of 1/2. Now we don't say -1/2, just say 1/2, dilated by a factor of 0.5, or if you wrote it as a fraction, half is fine, from the x-axis. Now it is important that you do say that it is from the x-axis, because as I said before, you can have a dilation from the y-axis and you can have a reflection from along the y-axis. So make sure you put in that x-axis part. We've gone to the left 5 units, haven't left much space, and then we've gone down 2 units. All right, so just identifying A, H, and K, and that's only when it's in turning point form. So if it's not in turning point form, then you can get it into turning point form by completing the square. What was I about to say? Yeah, so you can only really tell the transformations when it's in turning point form. Next year you'll learn about mapping and you don't need to change it, but you know, I always love converting it. I think it's easier to put it into turning point form. Anyway, let's move on. Question 2. Using the formation y equals a times x minus h squared plus k, determine the equation of each of the following. So a quadratic with a turning point of 2, 4 and a y-intercept of 0, -8. So we've got a turning point of 2, 4. So that means, so remember your turning point is hk. So h equals 2, k equals 4. And then if you've got another point, we can just say, and that any coordinate is xy. So x is equal to 0, y is equal to -8. And I think when I did this question, I didn't check what it's going to turn out like. So it could be a really complicated one. Let's hope it's not. I don't want to change colour. All right, so our general form, turning point form, is here. So it's just substituting all these 4 values in and then solving for a. So we're going to have -8 equals a, which is what we're solving for. X is 0 minus 2 squared plus k. Maybe I did think about it. So -2 squared is 4, so 4a, and I just realized we do have a value of k, which is 4 plus 4. Then we're just solving for a, so take 4 from both sides. So we've got -12 equals 4a, divide both sides by 4. So a is equal to -3. And then we just substitute it back into our equation. So x and y stay there. It's just like when you do linear equations and it's in the form y equals mx plus c. You always find m, your gradient, and c, your y-intercept, and then you substitute it back in. So it's the same for this. X and y remain. We're just substituting now a, h, and k. So it was h2, and then k is plus 4. All right, so there's your equation. Now, if you do have a lot of working out, it's a good idea to put a box around your answer, especially if it's in a random spot. All right, a quadratic. Okay, so remember h, k, and this is x, y. So h is equal to 3, k is equal to 2, x is equal to 2, and y is equal to 0. So we're just substituting that into your turning point form. What is x2 minus 3 squared plus 2. All right, take away 2 from both sides. Dip. And then 2 minus 3 is -1. -1 squared is 1. So a is equal to -2. So our equation is y equals -2, x minus 3 squared plus 2. All right, so just to recap before we move on, what I did here is we found a. All right, we had to find a. And then we substitute a, h, and k back into the rule. Now, x and y, remember, they're any point on the parabola. So they change, all right? They're variables, but everything else, a, h, and k, they take on the same value. All right, so 3, 2, was it 3, 2, and -2? All right, oh, we've got another one. Maybe I did think about the answers to these. Just seeing what I've got here. All right, h equals, what do we got? Oh, no, it's a different one. Okay. What was my question? Did I say? Oh, okay. So these have been thrown in. You can't use the, oh, you could use the turning point, but I'm not going to use the turning point. Probably should. All right, so this time, because we've got the x-intercepts, all right, you need to substitute them into factorized form. So remember, if these are your factors, you're going to have x minus 4, not your factors, your values of x, and these are your factors, x minus 2. All right, so remember when we did quadratics and we had to let y equal 0? So basically I'm taking these values of these x-intercepts and substituting them into the factorized form. And now all we have to do is solve for a. Okay, so if your x-intercept, I might just do this over the side, is at x equals 4, that means, and also if it's an x-intercept, y is equal to 0. So your factor, if we take away 4 from both sides, x minus 4 equals 0. So you can get your factor. That was a terrible drawing over there. Let's tidy that up. X minus 4 equals 0. All right, but your knowledge of quadratics, you should be able to pick that up quite easily. All right, and then we've got a y-intercept of 0, 24. So all we need to do is now substitute that into the equation. So we've got 24 for y, a 0 minus 4, 0 minus 2. All right, so then it's going to be a times negative 4 times negative 2, which is 8a. Divide both sides by 8. So a is equal to 3. So your equation, and you can just do it in turning point form. Now, if you wanted to do it in, sorry, not turning point form. We've done it in factorized form. If you wanted to do it in turning point form, probably the easiest way would be just to expand it and then complete the square. Okay, but you don't need to do that on your test. You could just leave it as factorized form. All right, and lastly, a quadratic that passes through the origin. So remember your origin is 0, 0, and the point to 8. So we can use the factorized form again. I'm just wondering if we've got enough information. Let's see. Anyway, so your first factor is x plus 0, which is just going to be x. And then your other, just thinking whether, I don't actually think we've got enough information. We don't have enough information with this one. All right. The reason we don't have enough information is we do need 3 points and we've only got 2 points. And yeah, because we don't have the x-intercepts, it's too hard. So cannot do. Not enough information. Sorry. That's all right. You will have questions on your test where you have enough information. That's just me doing some revision very quickly. All right, how are we going for time? Oh, 14 minutes in. Write the following quadratics in turning point form by completing the square. So you guys have completed the square so many times. All right, so remember it all comes down to the coefficient of x. So we're going to write y equals x plus whatever the coefficient of x is, 4 on 2. So the coefficient of x divided by 2, then square that. And then because we added 4 squared in, we're going to take it away. And then we've got 10 on the end. Now, instead of writing 10, I'm going to write 10 over 2, just so we've got the same denominator. So I could do that on the next line, but, you know, trying to save time in a test. All right, actually, what am I doing here? I'm trying to save time and I've made a boo-boo. Let's just keep it at 10 for now. I forgot to square that term. All right, so we've got x plus 2 squared. 4 on 2 is 2, 2 squared. All right, we didn't even need to convert it into a fraction. And that should be a 4. Okay, I shouldn't rush. When you rush, you make mistakes. All right, 4 minus 10 is negative 6. And that's turning point form. All right, we don't have to do anything else with that. We could sketch it. All right, we now know that our turning point HK is -2, -6. Our y-intercept, just your constant, it's already in expanded form here, so -10, so 0, -10. And it does have x-intercepts because it's a positive parabola that shifted down 6, so you just let that equal 0. So for your x-intercepts, let y equal 0, and I can just quickly do that. So we're going to have x plus 2 squared minus 6 equals 0. Add 6 to both sides. All right, so it's going to be, plus or minus the square root of 6. So we take the square root to get rid of the squared on that bracket, and then we take away 2 from both sides. Get rid of that. All right, so we're going to have root 6 minus 2 and negative root 6 minus 2. So they're your x-intercepts. You didn't have to do that for that question, but you will on your test, and probably a later question, but make sure you have them in your bound book. All right, question B, when we're completing the square, your coefficient of x squared does need to be 1. So in this case, it's -1. So we do need to take that negative out as a common factor, like so. And then we complete the square. So just make sure anything that is, because we've taken out the negative, anything that was negative now becomes positive, and anything that was positive now becomes negative. Now that negative has to apply to everything. So if we use square brackets, which are kind of like a lot more serious than the curved brackets, then you'll remember that that negative has to apply to everything. All right, let's just complete the square. So 6 on 2. Oops, that should be a minus. Minus 6 on 2. You could write 3 straight away if you wanted to. And then minus 4. All right, keep that square bracket there just for a little bit longer. All right, so 6 on 2 is 3. 3 squared is 9. All right, notice how I've kept the square brackets just until I've brought these two terms. So we've got -13. All right, so this is where you've got to make sure that this negative applies to everything. So it's going to be minus x plus 3 squared, and then that minus 13 becomes plus 13 because that negative sign is multiplying everything inside the square brackets. All right, with question C, again, we've got to take out the common factor, which is 3. All right, so just make sure it applies to everything. You could put your square brackets in now. I'm just doing a double check because sometimes you'd hate to go through all the work and then realize you did something very, very small at the very beginning. All right, so using your square brackets, we're going to have fractions as well. X minus 3 on 2. It's okay, we can deal with fractions. Should probably put a negative in there. Doesn't make any difference though. Just make sure I've done that all correctly. Okay. All right, so -3 on 2 squared becomes 9 on 4. And then that 4 I'm going to write as 16 on 4, just so we can add those two fractions together. All right, keep your square brackets because we're still dealing with the completing the square. So negative 9 plus 16 is 7. So plus 7 on 4. And then that 3 multiplies everything. So it's going to multiply this bracket. So you notice I just got rid of the square brackets. And it's going to multiply that 7 on 4. So 21 on 4. All right, so a little bit harder. The key thing you need to remember is when you take out a common factor, it needs to multiply both. Okay, so you complete the square inside your square brackets, and that 3, you know, just cruising along, going for the ride, and then at the end it says, hey buddies, I'm going to rejoin you. All right, so just remember that with the when you complete the square, that common factor gets taken out. Now I'm just going to pause because I always get conscious or self-conscious that I've made a mistake. Alrighty, we're all good to go. All right, question 4. I don't think we're going to get this whole video done in 30 minutes. All right, write the following quadratics in factorized form. Okay, so this is where you need your brackets. What I've been writing in pink. Let's get back to pink. Sorry, blue. All right, so there's no coefficient of x squared, which is good. So we can just say, all right, it's x, just setting that up. And then we need 2 numbers when multiplied give you -7 and when added give you -6. Now I did put a bit of thought into before I did this revision. Well, you know, not to obviously that earlier question that you couldn't do, but your 2 numbers are -7 and +1. So -7 times 1 is -7, -7 plus 1 is -6. Boom, we've done it in factorized form. Let's do the next one. Coefficient of x squared is 1, so nice and easy to do. 2 numbers when multiplied give you -10, and when added will give you 3. So it's going to be 5 and -2. So remember, factorized form lets you see the x-intercepts. So let's just do it quickly over to the side. So your x-intercepts for this one are at x equals 7 and x equals -1. You're basically just letting each of those brackets equal 0. So your x-intercepts for this one are -5 and x equals 2. All right. Now, next one. Whoa, we don't have a non-monic, but that's okay. And I've just looked ahead and we can't actually factorize the next one. Why do I do this? All right, let's do. Okay, so we've got to take out, let's see if we can take out a common factor, and we can. All right, so it's x squared minus 4x plus 4. All right, so we're just now factorizing what's inside the bracket. So think about that too. It's just cruising along. Doesn't have to get factorized. It's already been factorized. It's taken out. And then we're just dealing with what's inside the bracket. So we're going to have x plus something. Or in this case, minus something. It's going to be minus 2. And if you want to get a little bit fancier, which you probably should, just 2 times x minus 2 squared. Now this one, we haven't done too many examples in class, but that's only got one x-intercept, and that is at x equals 2. So your parabola, there's your x-intercept, sits on the x-axis. All right, so when it's a repeated factor like that, it sits on the x-axis. Now D, I know, is not going to work. Simply, so I write these questions, write the following, yeah, so we can't factorize the next one. And the reason we can't factorize it, and maybe it's good to talk about anyway, let's say, well, the whole purpose of factorizing is really to find your x-intercept. So let's go ahead and do that. So it's getting a bit temperamental. X-intercepts, let y equal 0. All right, so let's go ahead and let that equal 0. All right, let's try to solve it. Boop. All right, and we want to get rid of that squared, so we're going to take the square root of both sides. Now remember, when you take the square root, you've got to take the positive and the negative. So they go, and you're left with x minus 2 equals plus or minus the square root of, oh my gosh, you can't take the square root of a negative number and get a real solution. So that means there are no x-intercepts. Now I knew that, all right, from the very beginning, because this is a positive parabola. This part here is positive. The value of a, or the number in front of the bracket, is positive. So it's a positive parabola. This plus 16 means it's been shifted up 16. So your parabola, let's draw one again, your basic parabola, and it's, so there it is, x squared. And this isn't the exact one because this one's shifted to the right. Oh, maybe I'll do it. It's shifted to the right too. Okay, so h2 and then up 16. All right, so it's going to look something like that. So it doesn't have any x-intercept. So when it doesn't cross the x-axis, or it's not sitting on the x-axis, there's no x-intercept. All right, with question E. Now this one here, it's a non-monic, right? Because your coefficient of x squared is not 1. And we can't really take out 2 as a common factor quite easily. We'd be dealing with fractions. So this is where you would use your quadratic formula. All right, so x is equal to, what is it equal to? Negative, try to remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. I hope that's right. Maybe I should check. Awesome. Okay, so just identify a, b, and c first. 3 and c equals negative 1. Okay, so negative 3 plus or minus the square root of b squared, which is 9. I'm going to just cut a few corners here. Times 2 times negative 1. And that's going to be over 2 times a, which is 4. Let's just tidy things up a little bit. All right, so we're going to have 9 plus 8. Just make sure that's right. So the square root of 9 plus 8, so 17 over 4. Now I can't simplify that any further. So now I need to separate it. So we've got negative 3 plus root 17 over 4, and x equals negative 3 minus root 17 over 4. So they're your x-intercepts. All right, that's what the quadratic formula is giving us. So we can also write it. X minus 3 plus root 17 on 4. Sorry, I'm just thinking while I'm doing this. Should be a plus. And we're going to have another plus 3 minus root 17. Don't know what happened there. Over 4. So this is using your quadratic formula to find your x-intercepts. And again, I'm just going to do a sneaky little check. Now, if you guys aren't using photo math, oh my God, it's just like such a dream just to be able to plug something in, take a photo of it, and it checks it for you. Just going to make sure I can. All right, so we want the x-intercepts. Awesome, negative 3. Okay, so my x-intercepts are correct. And I don't think I can put it in factorized form, but that's all good. Okay, so might be a good example to have this in using your quadratic formula. You can use your quadratic formula for anything. Just remember when you're substituting. So what we found is, okay, let's just do this over here. So what we found here is your x-intercepts. So if x is equal to, and I'll just do one of them. All right, so if we're letting, say, the right side equals 0, we're going to take away, sorry, we're going to be adding 3 plus root 17 on 4 to both sides. So they cancel out, and that means we have to add, you know, because we're balancing the equation. So that's how you get this part here. And then you can do the same for your other x-intercept. So that the right side is now 0. Okay, so remember your x-intercept is when y equals 0. So you can just shift it over to the left side so everything's together, and that'll become your factor. All right, just conscious of time. How many, oh gosh, how many questions have I got? All right, I'm going to stop the video there because there is no way I'm going to do this. And I'll do the rest later. All right, so what are we up to? Question 5. All right.